Hello everybody. We are going to do our first video lesson on factors versus multiples. Don't forget, when you watch a video, you can pause it to write if you feel I'm going too fast, or you can rewind to watch it again. You can watch it to review for quizzes and tests, so keep these notes handy. They will be beneficial to you later. So let's look at factors. Factors are numbers that are multiplied together. So for example, 2 times 3, when you multiply the 2 and the 3 together, those are called factors. So our definition of a factor is 2 or more numbers multiplied together. So go ahead and write that. Now, if I asked you to find all the factors of a number, you would want to make a list of all the factors of a number. So let's look at 24, the number 24, and we're going to organize it in a T-chart. And we're going to think about factor pairs, starting with the lowest number that goes into 24. So that would be 1. 1 goes into every number, 1 times 24. That's our first factor pair. The second factor pair, going in order, would be 2, and 2 times 12 is 24. Next is 3. 3 times 8 is 24. And finally, 4 goes into 24 6 times. So 4 times 6 is 24. So if we counted them, we have 1, 2, 3, 4, 5, 6, 7, 8 factors of 24. Okay, let's look at factors of 100, again, using a T-chart. Factors of 100, if you know them all, they are going to be very helpful to you in the future of math. So try to memorize these. 1 goes into every number, so 1 times 100 is 100. It's an even number, so 2 goes into it. 2 times 50 is another factor pair. 3 won't go into 100. 4 goes into 100 25 times. I like to think quarters, or quarters in a dollar. 5 goes into 100. I like to think nickels. 5 is a nickel, and it takes 20 nickels to make a dollar. And then finally, 10 times 10 is 100. So there are 2, 4, 6, 8, and we're only going to count the 10 once. So there's 9 factors in 100. Now, that's what you do if you want to find all the factors. Now, if you want to find the common factors, you look at all the factors and circle the ones that both numbers have in common. So their 1s are in common, 2s are in common, and the 4s are in common. And I believe that's it. If I want to find the greatest common factor, or the GCF, I look at that biggest factor that both 24 and 100 have in common, and that would be the 4. So the GCF of 24 and 100 is 4. That's the biggest factor both 24 and 100 have in common. Now let's look at the greatest common factor using a ladder. This method is a little bit different, where you don't have to know all the factor pairs. So let's look at finding the greatest common factor of 60 and 45. Now I could list all the factor pairs in the T chart and then find the one that's the greatest, but I'm going to do this a little bit differently. I'm going to make what looks like a ladder underneath the 60 and the 45. And I'm going to think, what is one factor, any factor, that goes into both 60 and 45? And that is 3. How many times does 3 go into 60? 20 times. How many times does 3 go into 45? 15 times. Now I'm going to focus on the 20 and the 15. I'm going to do a next step in the ladder. How many times, or what is one number that goes into both 20 and 15? That number is 5. So 5 goes into 20 4 times, and 5 goes into 15 3 times. Now I'm going to look at 4 and 3. What one number goes into both 4 and 3? That number's 1. When I get to 1, that means I'm done. Now I'm going to take the numbers off to the side and multiply them together, and that's my GCF. So the GCF equals 3 times 5 times 1, which is actually 15. Okay, so that's another way where you don't have to list all the factors. All right, so let's look at a problem. When do we use GCF? Well, we use them when we want to arrange two rows or two or more things in rows or groups. So let's read the problem. Brian is making balloon arrangements. He has 8 blue and 12 green balloons. What is the greatest amount of arrangements he can make if he wants them to be identical? So let's circle the important information. He has 8 blue and 12 green balloons. We want to know the greatest amount of arrangements he can make. Let's underline the information we need to find. And the groups have to be identical. So in this case, I need to find the greatest common factor. I'm going to make a T-chart, and I'm going to tell you why as we're going through it. So let's make the factors of 12 and the factors of 8. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Factors of 8 are 1 and 8, 2 and 4. And I can see they have 2 in common, 1 in common, and 4 in common. The biggest one is 4. So if the GCF equals 4, that's going to answer our question, what's the greatest amount of arrangements he can make? But let's take a look at why the answer is 4 and what it actually means. If we look at the factors of 12, we can think he can have one group with 12, these are green balloons. Or he can have 12 groups with 1 green balloon. I don't know if we'd want that. He could have 2 groups with 6 balloons or 6 groups with 2 balloons. He can have 3 groups with 4 balloons or 4 groups with 3 balloons. Those are choices for group sizes. If we look at the 8 blue balloons, he can have one group of 8 balloons or 8 groups of 1 balloon. We wouldn't want to do that. Or he can have 2 groups with 4 balloons or 4 groups with 2 balloons. Since the GCF is 4, that means this is how we answer this question. He would have 4 groups. Okay, let's look and see what he would have in each group. If this was the GCF, this means 4 groups with 3 balloons in each group. So he'd have a green, a green, a green. There's 3 in that group. A green, a green, a green. 3 in the second group. 3 in the third group, and 3 in the fourth group. And that takes care of the 12 green balloons. If we look at the 8 blue balloons, we know there's 4 groups. There'd be 2 in each group. So the 2 blue balloons in this group, 2 blue balloons in the second group, 2 blue in the third, and 2 in the fourth. So that answers the question, what is the greatest amount of arrangements he can make? There's 4 arrangements. If he wants them to be identical, everyone's going to have 3 green and 2 blue balloons, and that takes care of all the balloons. So that's when you would actually use GCF. Okay. Go back in your notes, see if you understood. Come back and ask questions if you need to. Have a great night.